Welcome back once again, friends. Let us get started building the part 2 of the secret messages project. In this video, we'll see how we'll get started building a Caesar cipher. Now, the question is, what is a Caesar cipher? Well, Caesar cipher is a type of substitution cipher, which means that in Caesar cipher, we are going to look at the input string letter by letter, and we are going to replace every letter by a new letter. Now, how do we compute this new letter? Well, it's actually very simple. What we try to figure out is that the input letter, where does it exist in the alphabet? For example, letter A is the first letter, and we might say, okay, we'll replace every A with a D. For example, if we are shifting by 3, so every A becomes a D, every B becomes an E, every C becomes an F, and so on and so forth. Now, obviously, this is quite simple. This is just a starting point. It can be, this Caesar cipher can in fact be easily broken, but using this, we can actually build some more sophisticated stuff as well. I'm told that Julius Caesar used to use this. Now, if you want to get a more deeper historical and say a broader outlook about a Caesar cipher, you can look at this webpage. It's very interesting, very interesting to read. But we are here interested in seeing how we can build this in Python. Now, before I start writing the code, before I start actually, implementing this, we will look at this in a slightly deeper manner and try to understand what are the inner dynamics that are going to happen, so that it becomes easier for us to actually write the code. Now, the first thing, as I noticed, is that this is just an example shifting by 3, but really we can shift by many different values. So let's look at some examples. For example, if I shifted by 1 and my plain text, or let's say the input string was ABC, my cipher text or the output secret message would be BCD. Notice how A has become B, B has become C, C has become D. Say my shift was 10, then ABC becomes probably say KLM. If my shift was say 25, A becomes Z, B becomes A, C becomes B, and so on. Now there are two interesting things coming out from this table. You can also study the other examples. But the two important points that come out from this table, number one is that this is in fact circular in nature. And what do I mean by that? Let's look at this one. X, Y, Z shifted by 1. So X is going to become Y is going to become Z, but Z will again become A. And that's because Z is the last alphabet. So when it kind of, the next one, it just rolls over to A. And that's what I mean by this being circular. Number two, notice that when I do a shift of 25, it can also be viewed as a shift of -1. And what do I mean by that? Let's look at this one. So I do X, Y, Z. If I shifted by 25, and you can work this out, you will get W, X, Y. So it's also equivalent to saying that I shifted each of these by -1. So instead of moving forward, I in fact came backwards. However, for our development, we will consider every shift to be between 1 and 25. We'll talk about this reason for this later. But in the beginning, we'll just build this without the circular nature, and also, basically without the circular nature and without bothering about this shifting negative values and so on. Now, let's think about what do we need to build this in Python. Like I said, the first thing we need to do is to analyze the input message letter by letter, right? So we must see, okay, I'm going to look at every letter and see what I need to do with it. Now, this is in contrast, for example, with the previous algorithm, say even or swap or say reverse, where we did not really look at what was that letter. We just looked at the position because that was a transposition cipher. Now, we will here figure out where in the alphabet the specific letter appears. For example, letter A appears in the beginning of the alphabet, appears, letter C is the third letter, letter Z is the last letter, and so on. But what that means is that we will have to keep knowledge of, we'll have to store the entire alphabet for reference. And in fact, we'll do that. We'll keep a string which will hold the entire alphabet. And then once we know where the original letter exists, then we know where the new letter will be, because all we have to do really is to add the shift for the original index. So that's the idea. Like I said, the circular part of it, we'll look at it later, but that doesn't break the basic algorithm that we can use. Now, with all this background set, let us go back and, let us go back to our Python code and start building this. Remember, we had copied previously the secret messages part 1. So I'm just going to continue from there, but I'm going to just comment out some things that I don't think I'll need for now, right? So that the screen remains uncluttered, and we can just focus on the things that we need. So here I'm just calling, commenting out all these function calls, because we don't really need them. And I'm also going to define a new x called, say, ABC. We'll start with this, but we'll take more examples as we go along. But let us go and define now a function called Caesar cipher, right? So I'm going to say def, say CSAR cipher. Now this function will get two inputs. One input will be the x as always, because that's a string that we want to encode to convert to a secret message. And the next input is n, which is the shift we'll give, right? So we can in fact write for our clarity here, x is the input string, and n is the shift that we want. Now because we want to keep it quite general, we have seen that many shifts are possible, so we will keep it quite general. Now as before, I'm going to create a string called s, which will be returned later. I'm going to start it with the empty string. Now remember, I told you that for the Caesar cipher to work, I'll have to analyze the input string letter by letter, which means I have to really look at every letter in the input string. And for that purpose, an ideal construct would be a for loop. So I'm going to set up a for loop, and I'm going to say for I is just a variable, doesn't matter. The name doesn't matter. I in the range, say length of x. Now what this will do is that I will start from 0, but it will go all the way to the end of the string, because that's really what we want, right? We want to, um, we want to look at every element of the string. Now there are two scenarios. So remember, the string itself might be a sentence, in which case there'll be some spaces in between. So there are really two scenarios. I may have a situation where the specific character that I encounter is a space, in which case I don't have to do anything, just that I have to add a space to my output, right? So I'm going to write that first. So I'm going to come in here. Some reason my indentation went off. So I'm going to say if, say, x of I is equal to, say, a space, right? In this case, I'm going to say colon, and I'm going to just say s equals to s plus space. Now notice here, we are indexing into the string x. I is going to take values from 0 until, say, if the length is 10, so 0, 1, 2, 3, 4 to, say, 9. So we are looking at every element of the string and saying, okay, if that element happens to be a space, then all I really have to do is to add a space to my s, right? Because that seems logical. On the other hand, if it is, so okay, to be careful here, on the other hand, if it is not a space, which is the more interesting case in a way, I'm going to say if it's not a space, then remember I have to figure out where in the alphabet does this letter exist. But for that purpose, we must have the entire alphabet available to us. So before doing this, I'm going to come out of this function, and I'm going to define a string called, say, letters, and I'm just going to call it the entire alphabet, right? So it's going to be A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Now be careful on this. Make sure all the letters are present and in the right order, because otherwise the code will start to go for start to exhibit errors, right? But anyway, we come back here, and remember I have to figure out where in this alphabet does my letter exist. So I can use the find method from strings, because letters is a string. So I'm going to say idx is equal to letters, so letters dot find, and I'm going to say x of I. So what this will do is that it will return me the index of x of I inside the string letters, right? So for example, if x of I was a, then I'm going to get a 0, because remember, indexing starts from 0 always. On the other hand, if the x of I was, let's say, z, I'm going to get a 25, and anywhere in between I can get. Now having obtained this, I am going to say the new idx is equal to, let's say, idx plus n, because remember, n is the shift that I want. And all I really have to do now is that I have to replace the original letter with, let's say, letters new idx. So this time round, I'm indexing into the string letters, because that's the entire alphabet. So imagine if my idx was 0, my and shift was n, was 3, new idx will be 3. So I'm going to say letters 3, which will be basically a becoming a d. Now clearly this code is not complete. Like I said, we haven't yet built in the circularity part of it. We'll come back to that later. But first we will complete this code by saying return s. Now notice here that the return statement, which will return the execution back to the calling place, is aligned with this for. That's because we do not want it to be part of the for statement, for loop. We want this for loop to run completely, and only then do we want to call the return statement. So this indentation is very important. Notice that it's aligned perfectly with the for. And that's because it's one indentation down from the def itself. Now, before I call this function, I want to make a very interesting point, a very important point as well, that we have used here a variable letters, which is in fact defined outside a function. And the reason we are able to do this is because any variable that's defined outside a function is always accessible inside a function. However, the converse or the reverse of this is not true. If my variable is inside a function, then I cannot access this outside, as we have seen before. So for example, in this case, idx and new idx will not be accessible outside. Now let us just put a few print statements. So I'm going to say print, let's say I equals to, for example, I, then comma, maybe say idx equals to say idx, and I'm going to also say say new idx equals, and this time around I'm going to put new underscore idx. And the reason we are doing this is because we want to see what happens as this loop runs, because that's quite interesting. Now, to make, defining a function alone is not sufficient. We must also call this function. So I already have a string x equals to abc. I'm going to say x encoded is equal to Caesar cipher, and I'm going to say, for example, let's say x and say 3. So I'm asking my function to take my input string x, which is abc, and shift every value by 3. And we'll see how our code is working, because now we have all these print statements to sort of guide us. When I run this code, notice what I get is that so basically I come in here, the execution starts from x equals to abc. Next, I have this function call, so I pass in x as an input, as an argument. I get into this code, and basically I am going through every letter of the string x. I goes from 0, 1, 2 because the length of x is indeed 3, and none of the letters in the x is actually a space. So that's why, which means that for every I am going to enter in the else part, and I'm here printing I, index, and new index. So what happened here? The string was abc. Index, remember, was the index of the input letter in the list letters, in the string letters, and in this case will be 0, 1, and 2 because my letters were a, b, c. Since my shift is n, my new index will be 3, 4, 5, and indeed my xn, which is the variable that I've assigned the output to, is def, because really, because we want to shift by 3, so every a has become d, every b has become e, every c has become f. Let's take one more example. This time I'm going to give an extra space. So let's say here I go and say ghi, and perhaps I change the shift to maybe, let's say, say 5, right? You could try anything, but let's just see for ourselves. And this time, notice I've got a space in between, because that makes it quite interesting. So what happened here, right? Again, I have a print statement over here. So I called this function. Now notice for the first 3 letters, I have got index of 0, 1, 2, and hence new index is 5, 6, 7. Next, I have got I equals to 4. And why did that happen? Because really the x of 3 was a space, and which is why I'm expecting a space in the 4th position of my output as well. That's why I equals to 3 in fact went to this side. I equals to 4 again came back here, and again the same story started. I first found out where my input letter is in the alphabet, and then I found out the new index based on that. Now I keep doing this, and notice if I look at the x, e, and c, now I get fgh space lm, and remember the space came because my input had a space, and I'm just, if that happens, I'm just putting a space in the output. Clearly this function is not complete. We will see that with an example. So let's say I continued with this, and I went and told, maybe I'll just say make the space, make the shift as 1 just for the sake of clarity. For this example, let's say I go and set another space, and this time I said xyz. Now what happens is that this code runs, but at z, which is the last letter, notice my I was 10, index was 25 because my last letter was z, and idx became 25, but new idx now became idx plus 1, which is 26. That's why when I came letters 26, In fact, my string is index is out of range, because remember there are only 26 letters, which means that the last index is 25. Remember, the indexing always starts from 0. So now I have ended up in a situation where I have an error, and this is exactly the error we will fix by adding a modulo operator. And in fact, in that process we'll also end up making our code circular as it should have been to start with. We'll come back to that in the next video. I hope this was useful. Take care. Thank you so much. Bye bye.